If you're struggling with your cos and sine graph, so this video is for you. We're going to be looking at an example which reads like this. It says the depth of water can be described by a cos function. So they've already given us in this one that it's going to be a cos function. So it means you're not going to be stressed about that one. You already know that it's a cos function. We just have to make sure that we calculate the other stuff and pay attention to whatever they're saying. And one important thing to note in this unit is that you have to pay attention to whatever they're saying and the key wording that they're using within the examples, because yeah, that's basically where most students get it wrong. So now they're saying at 6 o'clock on Monday, the depth was at a minimum of 0.25 meter. 0.25 meter at 6 o'clock. You see? So, and at 3 o'clock on Monday, the depth was at a maximum of 1.75 meter. So now they're saying sketch one circle of the periodic function, your d is equals to f of t. Then in brackets they're saying d, the depth in meter, and t in hours since 6 o'clock. So you see now the key detail that gives you the starting point at this part. They've told you that you have your d is equals to f of t, so you have the depth in meter and t in hours since 6 o'clock. Since 6 o'clock, now it tells you that from the beginning or from the starting, this is like those same examples where you're drawing graph where they're giving you your t as equals to 0, you see. So it means now 6 o'clock is going to be our starting point. And if 6 o'clock is our starting point, what was happening at 6 o'clock? We had a minimum of 0.25. It means our graph is going to be starting at minimum. And one thing about cos graph is that if it is starting at minimum then going to maximum, that means that graph, it's a negative cos graph. So now let me just show you how I go about determining this. A normal cos graph, sorry, let me just get this thing. A normal cos graph is like a W shape. So normally you have something like this. So you would have a graph that's like this. So yeah, it's like this. Then it's more like a W. This would be your normal cos graph, you see. So if it's a normal, you see it would start at your maximum then going to your minimum. But now in this instance, what are we having? We're going to be having a graph that's going to be starting at a minimum. It could be somewhere here, then it's going to go up, then go down, you see. So those are some of the things that I just want to explain, that okay, this is a normal cos graph. Then what is a sine graph looking like? So your normal sine graph, you can just like note it by them as shapes. So you would have the first S in this line, then you would have the second S in those lines. So this would be your sine of f of x graph. And same thing with this other one. But for this one, if it starts at the middle, then it goes down, it means now we are having a negative sign of x graph. For this one, you see it's starting at maximum going down. So with the cos of x1, just to simplify it, always check your concavity. If you're having something like this, which is your concave up, this it's positive, you will know the graph is positive. If you're having something that looks like this, you will know it's concave down, then that one would be your negative. You see where I was saying if your graph is starting at the minimum, then going up, then coming back, that would be a negative cos graph, you see. So yeah, those are some of the things to note before we continue, and also with the other future examples to come. So already we know, okay, that our starting point, it's going to be at 6 o'clock, so we can just start calculating our values. That okay. Okay, before now we go to the values, I just want to make sure that also we've interpreted everything together. You see, for us, in order to be able to calculate our period, we know that your period is given as your 2 pi over b, you see. So now we have to work out our b, which is going to be the time in hours for this problem. So if we check carefully, they told us that what do we have? We have the time range between 6 o'clock and 3 o'clock. So if we check the difference between 6 o'clock and 3 o'clock, you would see that we actually have how many hours? We have 9 hours. We have 9 hours, but that doesn't give us a full circle. It actually gives us a half circle, because here we have the minimum to max. So just to put it into context, let's just say we have something like this. We have our minimum here, then we are going up, then here we have our maximum. So that's basically where we are at this point. So yeah, let me just do it like this and just say this, it's our 0.25. So we know that with our period, what is our period? You also have to know the definition of your period. They say a periodic function repeats the same cycle over, and the period is the time to complete one cycle. What do they mean by that? When I'm talking about a cycle, it means if I'm having this x-axis line and I'm starting here, I can either go up then come back to the very same line, or I could be starting this side, then I go down, then come back to the very same line. That's a circle, you see. So not necessarily a circle like this. In this chapter, we just regard the portion where you are having something like this as a full circle, as long as you are starting from this line and returning back to the very same line, that is your full circle. So you see now that we're only having half of the circle with this information that they've given us, you see. So now let's just say here, since they're saying since at the beginning, we can just say here we have what? Okay, we can just say here we have 0, then here we have 9, you see. So now it would mean we actually have to multiply this by 2 to have a full circle, because remember, our full circle must be something that looks like this. We are in need of this other space, we are in short of the other space. So that's where you're going to say your full circle is going to be 9 multiplied by 2, which is going to be 18. You see? So that's how you're going to get your 18 here. That's how you're going to get your 18. Then with this one, you can finish by saying you have your 2 pi over 18. This is the same as having okay, this is the same as having your pi over 9 when you're simplifying it. So yeah, it's a thing that you have something like this, and even if you try and use your formula, because you are moving from your minimum to maximum, and this gives you your 9 hours. So it means now you're going to say, now here we have t, you will say you have your t over 2 would be equals to 9 over 1. Then you cross multiply, you'll see that your t would be equals to 2 multiplied by 9. Then this will give you your 18. So remember, here we're having our t, this line we're having our d. See, so that's one way to explain it. So you have to be careful when it comes to the wording or the difference between the hours, just to see if indeed it's a full circle or a half circle. So in this example, it was a half circle. You have to multiply by 2 in order to have a full circle. So let me just draw it nicely now. Let me just finish doing the calculations, then we can come back and draw it, but we already have an idea of how it's going to look like. So the next thing that we can calculate is your amplitude. Your amplitude is given as what? It's your half into your maximum minus your minimum. This is the same as having half into, what is our max? 1.75. 1.75 we have 1.75 minus 0.25. then this gives us how much? It gives us 0.75. having 0.75. Then now what do we have to calculate? We have to calculate the vertical shift, which is our d. This is calculated how, or you always say you have your maximum value plus your minimum value divided by 2. You have your 1.75 plus 0.25 divided by 2. This is the same as having 2 over 2, which is equals to 1. So now that's it. It means we are ready to just determine the equation for the graph, and also be able to know to draw it, I meant to say. So we've done the period, we've done the amplitude, then we've done the vertical shift. So let's just go and try and draw the graph and see how it looks like. You know, in this side we're going to have our d, then this side we're going to have our t. We will start at our minimum value. Our minimum value is going to be, let me just write it here so that it's available. It's a 0.25. then I would just make it list maybe a nice spacing that from here to here. Here it's where we're going to be having that 9 hours, which is the difference between 6 and 3. But you know, since this one gives us half circle and they want 1 circle or full second, we actually have to multiply it by 2. We've talked about this, so now it means you're going to have your 18. So they say your maximum at 9. Remember, here it was our starting point at 6 o'clock, or where we can say it was at our initial point since 6 o'clock. So at 9, what did we have? We're going to be having that 1.75. We have that 1.75. So now it means we can be able to just plot. So meant to say we have this one, so we will have a graph that looks like this. It looks like that, but now we also have to include what? Our vertical shift. We know our vertical shift, it's going to be somewhere in between. So with our vertical shift, even with this one, I was supposed to at least maybe show by doing this. Then this one, this is where you're going to be having that one. Then you have this point here, and you will also have this point here. So how are those points helping you? These points are actually helping you. You will actually realize that these are the exactly point where you're going to be having your four quarters. What do I mean by 4 quarters? It means now from this side to this side, if I divide this 9 by 2, I'm going to be having my 4.5. You see? So it means now I'm going to be having 0, 4.5. If you add 4.5 to 4.5 plus 4.5, you get your 9. You get your 9 plus your 4.5, you're going to get your 13.5. So why am I adding this 4.5 throughout? Actually, how you work out these ones in the middle, you first take this period that you have. You would say you have your 18 divided by 4. We divide by 4 because we always have our 4 quarters. Have our 4 quarters as shown here. Let me just indicate by this, also by this, and also by this. You have 1, 2, 3, 4. Because your graph, no matter what, is just going to always look like this. Even if it moves to this other side or at the bottom, it will still have 1, 2, 3, 4 quarters. So that's why we always divide by the 4 quarters. Then if you take that 18 and divide it by that 4 quarters, you will see that it's going to give you the 4.5 that we've mentioned. You see, this is that 4.5. So as I said, if you don't want to use this way, you will know that okay, the distance between here and here, it's 9. In between, it means I must take my 9 and divide it by 2. Then that will give you the value in between that. Okay, now you have your 4.5. You see? So then, okay, with the other one, you know now this side you have your 13.5. The 13.5, if you don't want to use this method, you will say you have your 9 plus 18, which is going to give you your 27. your 27 divided by 2 is going to give you your 13.5. So it depends which one you want to use. You can use this 1 divided by 4, then get this 4.5, then you are adding your 4.5 going at that side, or you can work within the two spaces. You consider this left hand side and also the right hand side. You're adding, basically adding your 9 plus 0 divided by 2, you get for your 4.5. This side you're adding your 18 plus 9, you get your 27, you divide them by 2, you get your 13.5. so basically that's it on the ones in the middle. Then this is your graph. Now we have to go and write the formula. So we know that, okay, with our cos graph we normally have the general formula as what we have, a cos bt plus d. So the d is for what? The d would be for our vertical shift. Then the a would be what? The a would be the amplitude. But you'll see sometimes the other ones or the other lectures, they would put this d in the middle. You would still have the same formula, but it'll just be a little bit different, you see. So now it means we are ready to determine our formula for the function. We will go and check that, okay, what is our a? Our a, we've worked it out that it's 0.75. we're going to have our 0.75 cos of, what's the period? Okay, we're going to say cos of pi over 9 plus your d, your vertical shift, we got it, it was 1. So now we have to go again and see, are we finished? We are finished, but we have to check the shape of our graph. Our shape of our graph, it's like this. Remember what I said with the concavity of our graphs. I said if the graph it's like this, it's concave down, it means it's a negative graph, and if it's concave up, it's increasing, that means it's a positive graph. And also remember those examples that I gave in the beginning when I was starting with the lesson. So now it means you're going to be having minus 0.75 cos of pi over 9 plus 1. So yeah, those are the steps that you have to keep in mind, and just to run through it again. They had already told us that it was a cos function, and they also told us that at 6 o'clock they had a minimum of 0.25, then at 3 o'clock they had a maximum of 1.75. Then the only information that was able to help us determine or know our starting point, it was this 1, and also the wording that they use in bracket. They say sketch one circle of the periodic function d is equals to f of t, with d the depth in meter and t in hours, since from the beginning or from the starting point. That's why I was just saying here it's taken as if this is our t is equals to 0, you see. So in most of the examples, check for such wordings if it's there or not, and also check for information within there to know which one is going to be your starting point, because I know most they struggle with determining the starting point. Then other than that, another thing, it was just knowing that, okay, from minimum to maximum, that was only half a circle, and they want one circle or full a circle, which it's something like this. You're starting from this line going up, then you're coming back to this line. But if it's from 9, you see that you're only starting from minimum, then going up and ending on this part. So it means on this scenario they had only given you information that would cover only this portion. So you had to know that in order to have this one circle they want, you multiply this by 2 to get the full period, which was 18. Then you go and do your calculations as usual. Then you write your formula, you check the shape if it's negative or positive. So yeah, I guess I'll see you in the next example. I think yeah, we will look at a different one and see how are they playing with the weighting in the next example. So if you find videos like this useful, please support the channel by subscribing. So see you in the next video.